Hello everyone, welcome to the first session of Embedded Systems course with Arduino. In today's session, we are going to cover the brief introduction of embedded systems, its application domains, what are its basic features and characteristics, classification of embedded systems based on certain parameters, and what is the general design flow of an embedded system. So let's start. So embedded system in general is a combination of hardware and software. It's an integrated electronic system consisting of hardware and software, which is designed to perform a specific set of functions. It's not like a general purpose computing machine which can perform all the functions, but it will be designed to perform a desired function, right? So it's a combination of your hardware and your software, right? And if you see here, right, so this is a general layered architecture of your embedded system. So in the bottom you have your CPU or your processor, right? And then you have surrounding peripheral elements which can be your memory, which can be any other sensors or actuators which take input from the environment and give an output to the environment, right? And on top of that you have some operating system which is used for booting up the processor, and then on top you have a software, right? So as we said, like, it's a integrated system of hardware and software which is designed to perform a desired function, right? So this will be a general model of any embedded system. Okay, now where all these embedded systems are used, right? So in our surroundings, embedded systems are actually found everywhere. Okay, so you can take these examples, right? Your common consumer appliances, right? Your refrigerators, washing machines, air conditioners, then your biomedical instruments, right? Then your communication systems, right? And your normal peripherals to your laptops or your monitor screens and all that, your keyboard, your printers, right? So all those are very common examples of your embedded system, right? And I hope in your electronics and digital electronics lab, right, in your colleges and all, you would have seen certain CRT monitors and all those spectrum analyzers and all those. So those are also very common examples of embedded system, right? So here it's just a very, good representation of what all examples in our surroundings we have of embedded systems, starting with manufacturing equipment to, domestic appliances, as we discussed. Then you have all your audio visual components, and then you have your gaming consoles, right? Then your motion sensors, right? Your motors, right? So a very good example, right now, if those are amputite hands, right? Those are motorized hands. Like if somebody somehow lost their hands and all, now these systems are being developed, right? Which controls based on certain sensors, the output will be controlled to some robotic or monitorized hands, right? So then your cars and vehicles and all the robots which manufacture these in the industries are all examples of embedded systems. Your medical devices, your ECG machines, right? Your blood pressure monitors and all those, right? And of course your telecommunication equipments, your pagers and all those, right? So we see that everywhere somehow or the other we are surrounded by any means of common embedded system, right? So yeah, what are the basic features and characteristics of any embedded system? How do you say that this particular embedded system, right, or this is an general purpose system and this is an embedded system, right? How do you differentiate, right? So we have some very, unique and specific features which are only limited to embedded systems. So first is that these embedded systems are having limited resources, particularly the memory. So their footprint will be very small. In the same, why? Because the memory which will be attached to these or present in these embedded systems will be small, right? Because memories are costly. You cannot have large memories attached and then there is no use, right? You are making the embedded system itself costly. So the memory size will be small, the code footprint will be smaller, right? So that is one very unique feature of these embedded systems, right? And of course, you need only smaller memories and smaller code footprint because it is only performing one specific set of functions, not many functions, right? Then the second basic feature, which is very important, is that these embedded systems works against deadlines, which means that they are expected to perform their output in a certain duration, right? Not more than that. And otherwise, if that doesn't happen, some embedded systems are very, time bound, and they can lead to some heavy catastrophic events, right? So there should be very low latency, and they should be reliable and perform the output within a desired time. Then a very important feature is your that embedded systems are expected to consume low power. You whatever components or peripherals you are choosing to design these embedded systems, it's important that we choose them in such a way that they consume very low power, right? Because more power means it will be more costlier and all that. And since it is expected to run over long time, right, your power cost will also will be very high. So that will ultimately increase the cost, which is not expected, right? So another, as we said, that latency should be low and it should be highly reliable, and it should not be like you always need to reset the system, right, to make it work properly. For example, you are in middle of some treatment, and your medical equipment which is using certain embedded system or combination of processors and all that, which we'll see later, that resets in between, right? So that can lead to some unwanted results, and it can also like hamper someone's life or certain things, right? Similarly for military equipments and all those. So those are expected to be highly reliable. Now second thing is, your these embedded systems are expected to work in extreme environmental conditions, right? It doesn't matter whether it's very hot or very cold, your refrigerators, your washing machines, your air conditioners are expected to work accordingly, right? So this is also very important feature. Now of course all these features are required so that the cost of the embedded system should be low, right? So it's expected that these embedded systems are very cost effective, right? So this is also a very important point to remember for an embedded system. So in general, if you see any embedded systems, you will see that there these characteristics are present in that, right? And general purpose computing machines and all will not have these characteristics, right? For example, they will consume very high power for sure. So those features differentiate it from embedded systems. So this is just a so short summary of what are the features and characteristics listed in very short diagram. So small diagram. So if you see, it's for first of all, it should be very fault tolerant. It should consume less power, as we all discussed. Limited memory, small code footprint. Then it should be highly reliable, right? And then you have this, it should be highly then of course real time, right? You cannot expect it to take very large time to show certain outputs. It should be easy operable, right? Like through some switches and all that. Minimal interface means lesser number of peripherals. Otherwise, if you attach too many peripherals and it's expected to perform too many functions, then it will not be considered as an embedded system, right? And then of course, if you see here, it should be highly stable, right? It should be robust in the sense it should be time specific, and of course it should be task specific, which is that it should perform specific, and of course ultimately it's a low cost, right? Yeah, so what are the classification of embedded systems? So embedded systems can be classified into different categories based on certain parameters. So what we have listed here is based on the functionality and the performance requirements, right? So first is the real-time embedded systems, right? So real-time embedded systems are expected to perform outputs within a certain time, and if even if they miss their timelines, right, or they miss their deadlines, it can be classified into hard real-time embedded systems and soft real-time embedded systems. So for example, your traffic control system, right, is an example of soft real-time system. It may happen that once or twice during a day it may fail, right? So it will not hamper that much. Traffic police will be able to take control, right? There is a manual override. But medical and military equipments, right, if they don't perform the output, like if your rocket launches or your aeroplane systems do not function in real time, right, it can lead to major catastrophe. So that's important that we that we just take care of these real-time embedded systems, right? Now what next example is, next example is your standalone embedded systems, right? So standalone embedded systems, like you design a specific embedded system and it can work independently without being on any network or without being in any external input. For example, your refrigerators, you just switch it on, your washing machines, your air conditioners, right? All those things are, you just need a switch and it will work. So that is what basic examples are, your consumer electronic appliances. Then the next one is your network embedded system. So these embedded systems are expected to be connected to some local area network or some wide area networks through some wired or wireless communication links, right? And your examples are your quads, swipe machines, your ATMs. So all these, if you know, are connected to some network. Therefore, you are able to swipe your cards. It connects to the bank, some links, external web links, and therefore you are able to do these transactions. And most common example is your mobile embedded systems, which you are handling day to day, your mobiles, your personal digital assistants, right? Your small MP3, MP4 players, right? All those things are example of mobile embedded system, right? Now let's move to, yeah, what is a general model of an embedded system, right? What are the basic components which will exist in every embedded system? So this is the diagram represents the same, right? So basic thing is, the first very basic thing is your CPU, right? It will have a processor to manipulate the inputs which it is getting from the external environment, right? And display it or output it to the external environment, right? Then of course it will have memory, right, to store certain information, right? And then what are these sensors and actuators? So we talked about peripherals, right? So these peripherals are actually these sensors and actuators. So sensors, what they do, they take an input from the external environment, right? And they are passed through some hardwired units, so through some hardwired units in the sense, so these sensors will take analog information, right? Now you need to process them into some digital information so that it can be further processed by the CPU. So you convert through analog to digital converters, and of course you sometimes have digital inputs, and you need to output it again in analog information. So that is why you have digital to analog converters as well, right? So now once the input from the environment comes through sensors into through these hardwired units, it gets manipulated through the CPU. The information is stored in the memory, right? And then also you need to display it, right? Or you need to perform certain outputs. You need to display on certain the LCDs, right? Or you need to run the motors based on certain temperature inputs, or you need to decrease the speed and all those. So whichever is performing some output function, right? Your motors, or some other types of your display LCDs and all that, which is displaying information to you, that also is controlled by these CPU. Means ultimately the processor has to manipulate and put out that information to the user, right? So any embedded system must consist of a CPU, must consist of a memory, and it must consist of a peripherals, which includes your sensors and actuators, right? So these are basically, also you can say these are system buses, right? Which are shown by arrow. So these are your system buses. Okay, this can be address bus, control bus, data bus, but these all things we'll study in detail in the later slides, right? So I have given a very common example of, we are trying to design an embedded system. So what is this embedded system is doing? This embedded system is monitoring the temperature, right? And based on that temperature inputs, it is trying to control your heating, ventilation, or your air condition units, right? And also it is trying to display the information on an LCD, right? If you see here, this LCD is here, right? So we will display the information on this LCD. So what it is having, right? So if you see, this is your processor, right? And so as you told, we have a processor, right? And then we have some peripherals. So peripherals, in the input we have an temperature sensor, right? So in general, your temperature sensor will be an IC module. So in market you will get it as LM35. There will be a temperature module which you get, an IC you will get LM35. So that you integrate to as a sensor unit through some hardwired logic. Means so I will show that we'll use the Arduino, right? What will the course here, right? So this will be your Arduino. Ultimately we connect the temperature sensor to the processor, right? The processor will have certain software or firmware dumped in it, which will manipulate this, right? And once you make sure that the system is on, right? The temperature will be monitored, and based on the logic you want to display or you want to control certain things here, right? So this is your HVAC system. So HVAC is nothing but this can be some you know, motor to control the fans or to control your ACs. So this is your external output where it will go, right? And from here you can see it will be, this is your sensors peripherals, right? This is your actuator, right? And of course, so these all things will be embedded in the Arduino itself, the clock and the ROM where your software will be dumped, right? So in general, we saw like this is a general model of an embedded system as we had discussed on the last slide, right? And of course, we will design this also when we come to the Arduino part of our course. We'll try to design a temperature monitor, okay? So now what are the steps in the development cycle of an embedded system, right? An embedded system or whichever, right, your refrigerator, your ACs, or all these are manufactured based on, you know, in a certain way or in certain steps. So general steps are what? So first is the concept definition. So based on the consumer requirement, or right, whoever is ultimately going to consume your product or use that product, we derive certain concepts or definitions like what this embedded system is going to do, right? Based on that, what we do is we, right, we design a top level architecture, you know, what are the components or blocks this embedded system will consume. We try to design that system level diagram, right, block wise. So that is your system architecture. Post that system architecture is designed, and whatever the blocks or subcomponents we are going to use, what we have, so yeah, we'll have this hardware design. Hardware design, we'll be designing the front end using some SDL languages and all that. So this will be a proper design code, right? And in parallel, what we will do is you will have a software development going on, which will ultimately be dumped on the ROM, or we saw, right, you have a memory module where you will dump this, right? So that the ultimately the embedded system reacts in certain way. And of course there will be testing, right? So there will be testing also on this hardware design before ultimately the product is ready, right? Product prototype is ready. Then of course there will be post silicon, or you know, post the product is ready, there will be again testing and validation, right? And ultimately it will, you know, go to the consumer. And of course there should be support, and you know, this product should sustain over a long time, like it should be reliable. So these are the basic, you know, steps involved in the development cycle of any embedded system. Thank you.